Hi, welcome to the breadboard and introduction to a set of videos I will be releasing with my daughter over the next few days on how to make a 3D mask of your own skull. This video is going to be a very short overview of what you're going to find in the subsequent videos. They are quite technical and a little bit long in each one, of anywhere between about 20 minutes to a little over half an hour for each one, and there's probably about 5 of them. And in this case, this skull that you're actually looking at right now is my daughter's skull with a great big dent in it that was caused by an accident she had a while back, where she fell and hit her head and ended up needing a CAT scan so that they could see what the damage was to her skull. We managed to get a copy of that and have been able to put together this set of videos to show people how they can actually make it into a 3D model for printing or for some other kind of fabrication process. The steps involve a number of free to download software tools. The only real cost is probably printing or manufacturing the final mask at the end, and a bit of pain at the beginning where you have your accident and get your CAT scan done. So don't recommend going out and falling over and deliberately hurting yourself in order to do this. You can find plenty of CAT scans on the internet if you don't care about it being your own skull. I just want to take you through briefly what the process is at a high level, and then subsequent to that I will be releasing all of the videos in quick succession. My daughter Jessica and I have worked for quite a long time to figure out how to do this properly. There's lots of information out on YouTube and various other places that talk about how to do this, but none of them we were able to follow through and get some satisfactory results out of. So we were determined, and we set to figuring out how to do it, and we now have a pretty good process that will allow us to go right through from start to finish with fairly consistent results. For this video, I'm just going to walk through this PowerPoint presentation talking about some of the processes that we applied to create the final result. So, quick overview of the process. First of all, have an accident involving a severe and sharp blow to the head requiring a CAT scan so that the doctors or the surgeons can verify the extent of the injury. Free, but very painful, not recommended. After the CAT scan and regaining consciousness, of course, request a copy of the CAT scan for your doctor. Normally this is free, or it certainly is in Canada and Ontario. Take a copy of it for yourself before you hand it over to the doctor so that you can play with it. Usually this has some kind of viewer in there as well, so that you can look at it in the original medical imaging software. You want to convert the CAT scan into a 3D model as an STL file. We used a product called Inviz 3.0. We did try a few other ones, and we spent a long time, and we're talking like probably tens of hours, investigating various things to try and find out the set of software that worked well. Inviz 3.0 did work consistently and gave us models that we could work with without too much effort. This is a free download, and we will need 2 models to be exported from this. One that includes the face with the skin but no hair, and one which is the skull. We then used Meshmixer from Autodesk, which is another free download, to clean up the still models and also to scale them, the face to 102% and the skull to 132%. This way we can use this face to make an impression on the inside of the skull so that it will fit you. Then we used Blender, which is another piece of free software, to basically punch a hole or make a profile of the face into the back of the skull, and this then gives us the perfect mold for the mask, so that once you print it or manufacture it with some process, it will fit on you nicely, assuming you print it to the right scale, of course. This is just a simple view of the skull as it is seen using the standard medical CAT scan software that came on the CD. So loading into Inviz, what you do is you do a file import, and you give it a path to the folder containing the DICOM images. When you do this and you hit OK or whatever the prompt is, you'll be presented with the different image map sets that are on the CD. You want to pick the one we found with the most images in. In this case, it was the one with 240 images. Click on Import, and it will end up giving you a view similar to this. Now on the left menu, you'll see a button that says Create Surface, and near that there'll also be a checkbox to say Overwrite Last Surface. Click the checkbox so it's on, and press the button to create a surface. You'll end up with a skull in the bottom right hand corner, or whatever the standard default settings produces for you. And with this, that is the skull is what we want to start manipulating this 3D model in order to output our face and the skull. So by changing the settings in this little slider box on the top left of the Inviz application, you can look at different densities. So what this first slide shows us is that I've moved the slider to about 850 or negative 850, and you can see, we even see the hair and everything else. If we slide it to 226, we get just the piece we need for the skull. And playing around with the values, we found for this particular CAT scan that a value of -300 gives us the skin and the whole profile of the face and everything, but it doesn't include the hair or anything. Now, for each of these settings, once you find out the one that works for you, you need to export a still image of that model, and you use option 4. So down here on the left of the menus, you'll see that it has a number next to each of the little tabs or work pages. Click on the number 4 one with the down arrow, and you'll see that it has export using as a still or as a 3D surface. You click that, give the file a name. Now make it something that you're going to remember and know where you're putting it, because you're going to need to find it later. Do that for the skull, do it for the face, and then we can move on. We're ready to use Meshmixer. So exit Inviz and load up Meshmixer. Now the basic same process applies for the face as well as the skull. I went through this with Jessica a number of times, and we found that the best way to fix this is, first of all, when you load the model, is to have a look at how many errors there are. So if you use the select, erase and fill right away, you can fill in some of the holes, like the blue at the top indicates there's a hole. But if you initially do an analysis inspector to look at the model, you'll see all these pins effectively showing you where the errors are. Now you may find that there's a whole bunch of artifacts inside the skull, because it's just a surface model, or inside the face, that are going to make a lot of errors, and you can just use Meshmixer to clean those out before you fill in the holes, because we need this to be a solid. I would suggest giving it a try first though, but manually fill in the hole in the top of the skull and in the top of the face using the select tool. Click the perimeter and just double click. It will flip around the whole perimeter, highlighting it, and then if you go edit, erase and fill and use smooth MVC, it will try and replicate the curvature of the skull to fill in that hole, which is great. And that's what I'm showing here on these bottom ones. We select the perimeter, we tell it to fill, and you can see it's nicely filled in the hole here. We did the same for the face as well as the skull. On the bottom, you can see there's also a hole, and there's a lot of little artifacts like the inner ear canals and things like that, and these are some of the ones that are creating these red dots. And if you find that Analysis Inspector with the auto fix does not fix all of the issues, you might find that deleting these first will make the job a lot easier. I found going in from the ear and just cleaning it out and then doing a select, invert and delete everything else was the quickest way of achieving that. And we'll show you that in the detailed video anyway. The other thing we did at the end of this, for each of them, you can see there's a few artifacts left lying loose that are not part of the main model. If you double click on the main skull or the main face with the select tool, it will highlight the whole thing in like this orange color. If you then press I, it will invert the selection. So everything that was part of the skull is unselected, and all of the loose items are now selected. Now if you just hit delete and confirm the deletion, you'll get rid of all of those. The next step we have to do is we need to scale the skull and the face slightly. So when you do this, I found that making the face about 102% allows a little bit of space when you put it on, so that your hair and things like that don't get squished tight to your head. We also found that enlarging the skull to about 132%, 130-ish% is good to fit the face inside it. Now, you want to have the skull and the face as solids if possible, so using the Edit Make Solid within Meshmixer allows you to do that. Now, it does bring them back in a lower resolution mode, and there are a couple of sliders, Mesh Density and Solid Accuracy, sliding these both to about 200 or just a slightly over, and then telling it to update the re-render. It gives us what we found to be a reasonable resolution model that we could work with without the file getting so big that it doesn't work. Using the Edit Transform allows you to do the scaling. Now, one thing to be very, very aware of is do not move the model from its location. You can rotate it around its axis, but do not move it, because if you do, it'll make it harder when we want to put the face inside the skull when we go to use Blender. And then the final thing before you export these as the new STL files, run the Analyze Inspector again just to do any last minute repairs of anything that might have errored out while it was doing scaling and any other cleanup activities. It should export cleanly without any error messages popping up about the complexity of the model and things like that. If it is complaining about the complexity, then you probably need to go back and do that little bit of clean out inside the skull that I mentioned. Okay, now the next step after we've got the face and the skull ready to go is to open up Blender, and we're going to use the face to basically profile or cut out the back of the skull so that it will fit on your face correctly. Now in this case, the skull CAT scan is from Jessica's own face and skull, so we know that using the face we have is going to fit Jessica perfectly. If you have a skull image from somewhere else, you'd need to get some kind of 3D image of your face that you can use to mark out the inside. Otherwise, you may just have to try emptying it out as much as you can, and then you might have to take a file or something like that to it, or some padding to make it fit better once you've created a physical model. The first thing you do when you open up Blender is you import both of the STL files. When you do the first one, I prefer to pick the skull first because that's the main object that we're interested in, and then import the face. Bring them in, but don't start trying to look for them. I found that they didn't appear on my screen because of the size of them. They were way off out in the ether. They will both import to the exact same point in space in Blender, and once you've got them both loaded, just use your mouse, put it to the slightly upright corner I found of the origin markers here, and then use your scroll wheel to zoom out, and you will find that the model will come into view. Once you've got them loaded in and zoomed out and you've found the skull and the face, they should be merged together a bit like this up here. You may find that you need to reposition the face a little bit. Now you'll see that there are some arrows here. There's a green one, a blue one, and a red one. I found using the green one to push it forward as much as possible into the front of the skull without it coming out the front and leaving enough thickness in the skull to be able to have something strong when you still print it. And then I verified vertically up and down so that the ears were protruding roughly in the right place on the skull, and you can see the imprint in the skull where the ear is supposed to be. Once you've done that, then you select the skull as the primary selected object, and on the right hand side of the screen up here you'll see a little toolbar that has a wrench on it. When you click the wrench, you'll get this little menu available to you, and it should tell you the selected object is currently the if it says it's currently the face, you need to change that to say it's the skull. You select a modifier here of Boolean and the operation to be difference. This allows us to take the one object and actually subtract that space from the other object, and we're going to use the face to subtract away from the skull. Once you've done that, you can actually then select the face again, press the delete to get rid of it, and you'll see you're left with something like this bottom picture here, where the face actually didn't touch certain aspects. It left them floating and completely loose. And I already described to you that when you go back in Meshmixer, you can double click on the skull with the select option. So this is after I've highlighted the main skull, hit the I key, and now you can see all these other items. You press the delete, and now you're left with this thing at the bottom. So this is almost ready, but you now need to use Meshmixer, and you want to delete all of these inside pieces that are going to get in the way. On the nasal cavities, just to either side of the nose, you want to fill in these to add a little bit of extra strength. And on the inside, you're going to need to fill out part of the model so that you can make your face fit a little better. And you can see these areas that we need to fill in. And then this is looking actually from the back down here towards the front. And you can see these areas, this up here where the skull actually was imprinted with the face on there. And you can see a couple of small points down here that were touching, but not too many places around here were actually profiled very nice. So you want to fill these out using Blender and then reapply the face to it. So you just loop through that cycle a couple of times so that you can actually get this all nice and neat and fitting. You'll also find that the face doesn't come all the way down to the bottom of the skull, so you'll need to use Blender again to model that down a bit. You can actually see here a little ridge right here, which is where the bottom of the face finished. Now if you have a CAT scan that is of the whole head, then you probably won't get this issue if you're just making a just below the nose kind of mask. In Jessica's case, they were only interested in the head injury, so they stopped the CAT scan just below the nose here, and they actually didn't even start it at the very top of the head, which is why there was a hole in the top of her head as well. Once you've done that, again you go to in Blender, you just go to export the final model as a still file. Again, give it a different name, and you end up with a nice 3D model a little bit like this one, where you can, it's all nice and smooth inside, and it's ready basically for a bit of blending to clean it up. So going back into Blender, you can clean up this model, and once you're done, then you can go back into Meshmixer. And if I bring up one of the models that we had done already, this is the one that Jessica had completed by using Meshmixer. You can see here we've taken away a bit of the back of the skull in Meshmixer. So we went from the output of Blender, which I showed you just a moment ago, and in Meshmixer it's all been filled out at the front here, and the back has been cut away so it's going to fit over the head a little bit better. The bottom of the eye sockets have been filled out. That makes them a little stronger when you're trying to wear it. But what we now need to do is we need to reapply the face into this. So you can just take it right back into Blender, put the face back inside, and go through that same process. And the nice thing about that is it's going to make it more of a comfortable fit. The other thing that we did to finish this off was to move the face just slightly back when it first went in, or before you move it forward. Delete the interior of the skull first, and then move it forward for a better front face fit, and then do the deletion again. That way it leaves a little bit of extra room in the back of the skull for your hair and things like that, which haven't been accounted for in the sizing. The other thing you could probably do is make the face, or the whole face, a little bit bigger with it by zooming it out, like scaling it up a little bit more. But you do run the risk of it being a loose fit around the front as well then. If you want a tight fit around the front, I suggest you just have the skull backwards a little bit, then move it forwards to do that final impression on the front of the skull. Once you've done all that, you could then save this as a still file again, or as an OBJ file, and take it into your favorite manufacturing tool, whether that be Slicer, Cura, or whatever else you may be carving this out of or making it with, and print it. You can print this as a small model, and Jessica has some probably with her that she could show you if she hasn't already, that we printed at home. But the basic idea here is that you can just then take it to to print it. Now the idea we have, my printer right now at home is not big enough to print this, is to make it into an actual wearable mask, which we will end up doing. We just haven't got that printed yet. And that's pretty much it. I've taken you through the entire process at a high level. There is well over an hour. There's basically 5 videos that run from about 20 minutes to a little bit over half an hour or more for each stage of the process. It's quite detailed, but it works. So these will all be getting put onto YouTube on my YouTube channel over the next couple of days. So if you do want to reproduce this, there's not enough details in this quick overview for you to do that, or well, there's a reasonable amount, but if you want the full story to be able to follow it, then have a watch of those videos, and well, yeah, you'll see how much fun it is. And as I said, the only trick is to get the CAT scan in the first place. Or you can just download a CAT scan off the internet. There's a few there that you can get that are anonymous, and use your phone or something to make a 3D view of your face and try and make an impression on the inside of the skull, or just manually cleaning it out as best you can and try and use felt or foam or something to pat it out to fit you better that way. Another option that we found, which is one of the first ones Jessica actually created from this process while we were experimenting, was to only have the front part of the face, like just as a simple face mask rather than a full helmet. And that, of course, would be cheaper to print, probably easier to fit to somebody because you're only working on the front part of the face as well. But it's up to you. We just wanted to share the process that Jessica went through. I helped her try and figure all these things out because it's the kind of thing I do as well. And I helped her make the videos and put a bit of voiceover like what I'm doing right now for her. But yeah, it took a lot of work to figure out how to get all of these things to work well together. But now that we've got it, we wanted to share it with everybody, and here it is. So this is the first part. As soon as the other videos are up, I'll add links in the description on the YouTube channel for this, and hope you come back and watch it if you're interested. Anyway, if you like it, you know the drill. Okay, bye.